Welcome back to our expressions unit. Our last step is proportions. Proportions are equations where two fractions are equal to each other. Now, we're going to be using these throughout the year. They come up on SAT problems all the time, application problems, and a lot of percentage problems. So we're going to cover it all. But basically what we're going to do is we're going to have two fractions and we're going to have to figure out how to solve them. And really, you might remember that we cross multiply. We can do this because there's an equal sign in between. We do not do it if it's just A, B times C, D. There's no equal sign in between. This is a different process. This process, because there's an equal sign, says A times D equals B times C. This process is just multiplying fractions. That's A times C, B times D. This is an equation. This is an expression. You notice that this started off with an equal sign. This started off with just a multiplication. I added the equal sign because I simplified it. I'm solving versus simplifying. That is the big divide between these proportions. We are going to be solving proportions here. So, using that equation, or that expression, you might remember this back. But if I'm going to solve this proportion, all I do is I do 3 times C and 4 times 4.1. What I get is 3C equals 4 times 14.1. Well, 4 times 14.1 is 56.4. Now, how do I solve that? Well, it's 3 times C, so I'm going to divide by 3 on both sides. Divide that by 3, and C equals 18.8. Oftentimes, these proportions come up with application problems. So, Lori drove 232 miles in 5 hours. At this rate, how long will it take her to drive 580 miles? Well, I'm dealing with two things, miles and hours. So I'm going to set up miles over hours. So I'm going to set up the first fraction, 232 over 5. 30 miles over 5 hours. Should be the same rate as 580 miles over, well, how long did it take her? I don't know. That's my x. So now I have a proportion that I can solve. 232 times x is 232x equals 5 times 580. 2,900. Now I divide by 232. My x is 12 and a half. That represents 12 and a half hours. Now, does that make sense? Well, she went 232 miles in 5 hours. If I double that, that's 460. That's 10 hours. So yeah, that seems about right in my answer. Now, the most common thing with these problems are percentages. We use the same proportion setup, except for I use what we call is over of equals percent over 100. Because percentages are out of 100. So what this is, it says part over whole. Is another way of writing is over of. Part over whole equals percent over 100. Percentage is out of 100. So we set up these percentages so we can solve. So find the part or the whole. Well, what is the what number is 1.4% of 15? So what we do is we set up the proportion. So 100 is always here. Percentage goes above 100. 1.4 is a percent. 1.4. Now we have to discover, is 15 the part or the whole? Well, we do that by saying is over of. What number is? Well, that's my question, so that's my variable. Or I can think of it as of 15. If it says of 15, that's my of. Now I can cross multiply. 100x equals 15 times 1.4, 21. I divide by 100. And I get 0.21. Now I would repeat the process here. 225 is 36% of what number? Well, 36 goes above here. 225 is, that's my part, of what number? That's my x. So I would cross multiply. 36x equals 225, 22,500. I divide by 36, and I get x is 625. So every time I'm finding the whole or the of, I'm going to have a bigger number, typically, because 225 is 36%, meaning it's smaller than the big number. Every time I'm finding the is or the part, I should find a smaller number than the whole. The next piece is finding the percent. So in this case, 48 is what percent of 52? Well, now I know the 48 and the 52, I don't know the percent. I set up the same proportion and I cross multiply. 52x equals 4,800. I divide by 52. My x is 92.31%. So that's how I would solve these percent proportion problems. And all I'm going to do is rotate which of these three values has the x. The 100 is always a constant. It's always going to be there. Please complete the practice problems. Come to me with any questions. And feel free to email me or come find me during any of your downtime. Thank you.